The Metcal Tip cartridge contains a heater that consists of a copper core and an outer layer of magnetic alloy. It's the composition of this special alloy that predetermines the tip temperature and keeps it regulated at the solder connection. Surrounding the heater is an inductive wire coil through which an RF current is passed. A phenomenon known as skin effect causes the current to be confined to the outer layer of the magnetic alloy, resulting in high resistance that causes rapid heating. As the alloy heats up, it approaches its Curie point temperature. This is a physical constant at which the alloy's magnetic properties change. As the properties change, the current spreads through the whole heater, reducing the resistance, which effectively reduces the power delivered. This immediately stops the heating effect. During soldering, as the tip cools, the alloy falls below its Curie point temperature and regains its magnetic properties. The skin effect immediately returns, increasing the resistance, and heating begins again, repeating the cycle. As this occurs, the tip self-regulates very close to the Curie point, plus or minus 1 degree Celsius at idle. The temperature can never exceed the Curie point, just as water will only boil at 100 degrees Celsius regardless of the amount of heating power. In effect, Smart Heat regulates the amount of power delivered to the solder joint. The result is a system that responds dynamically to thermal loads and requires no calibration. Smart Heat systems apply direct power to the solder joint.